Hey you guys, welcome to Algebra 2. This is going to be our first unit in our series, and this is going to be our first set of notes. So we're going to name this set of notes 1.1. Okay, we're going to start out pretty light, and then it will pick up a little bit of pace as we go through these notes. But this is kind of just a refresher, just to remind you some basic concepts for algebra. All right, so we're going to be looking at real numbers in the real number system. And the reason why is there are some numbers called imaginary numbers. And we're going to see those later in Algebra 2. But for right now, we're going to get acquainted with these concepts or these vocabulary words. So for real numbers, we just use the letter R, okay? When you find an answer and the possibility is all real numbers, don't get that mistaken. It's going to look more like this. It looks like an R, but with two lines, like that. Okay? Kind of like the money symbol. Real numbers consist of the following sets of numbers. So all the numbers we're going to talk about are all real numbers. Okay? And you'll see situations where a number is going to fall into both a real number and an irrational number or a rational number. So we're going to go through those. Irrational numbers are all by itself under the real number system, and they're numbers in which the decimal form never terminates and does not repeat. So that's important. So never terminates. You could think about like pi, for example, 3.14 dot 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 because it goes on and on forever. It doesn't really make sense for a number to go on and on forever. That's why it's irrational. And what's important is that it does not repeat. Okay. So common examples are pi and non-perfect square roots. Okay, we'll see that in just a minute. Rational numbers, on the other hand, consist of all the other real numbers. Okay, so this is kind of like we can see this picture over here. Okay, and we can see so this little bubble right here would be our irrational numbers, and we would say this is I. Okay, and inside this whole box, everything inside this whole box is a real number. And in this small portion over here is irrational. Rational, on the other hand, is the first set, or the outermost set of real numbers. And for rational, we use the letter Q. Okay. And under rational numbers, they include decimals, either that repeat, and rational numbers can also be written as a fraction, where A and B are integers. Okay, so that would be like A over B, and these are integers. And integers are um, what we're going to read next. So integers include negative numbers, 0 and their opposites. So let's start at the bottom. I think it makes more sense to start at natural. Natural numbers are our counting numbers. If you want to write that down, I would. When you're playing hide and go seek as a kid, right, you don't start counting at 0. You don't say 0, 1, 2, 3. No, you say 1, 2, 3. So you could think of our natural numbers are all of our counting numbers, okay? That excludes, it does not include 0. The whole numbers, the only difference between whole numbers and natural numbers is that it does include 0. We can see that 0 is there. And then for integers, integers are whole numbers and their opposites. Okay, so this would not include our negative 2.5 or negative 2.3 or 1.5, right? Those are going to be our rational numbers. But for integers, they're the whole numbers and their opposites. So let's write that down. Whole numbers and their opposites. Okay. Alrighty, so let's go ahead and make a few notes on how we might see rational numbers. So natural numbers, they get the symbol N, N for natural. And we see some examples up here. We see that 1 is a natural number, 2 is a natural number, but what else is a natural number is this right here. What's the square root of 9? The square root of 9 is 3. When we simplify that, we get a natural number. So you could say the square root of 5. You could even say that 22 over 2 is a natural number because even though it's a fraction, it simplifies to 11, and 11 is a natural number. So those are good examples. Whole numbers, let me get a different color. The symbol for whole numbers is simple. It's just W, just like the word whole. And when we have whole numbers, we include our 0. And it's all of these included as well. So we have 1, 2, 3, and so on and so on. You could even have a fraction like this, 20 over 4, and that reduces to 5. So that is a whole number. You could even have the square root of 16, which equals 4. Okay. All right. An integer. Integers do not have the same symbol. Okay. Integer is a Z. So actually, let me use a different color. And before I do that, let me fill these in. So the bottom number, right, the very bottom is going to be our natural. So n goes here. Whole numbers are all of our natural numbers and our whole numbers, which would include 0. And then integers gets that symbol z. And that's going to be this right here. So one way to think about it is that an integer is a whole number and a natural number, okay? An irrational number is an integer, a whole number, and a natural number. So that's why we kind of have all these circles in each other. All right, so an integer, our whole numbers and their opposites, okay? So if we have 0 and we have 1, then we also have -1. Right? If we have 2, then we also have -2. Okay, those are all integers. You might even see that as, let's say, the negative square root of 16. Well, the square root of 16 is 4, and the negative is on the outside. It's not inside the radical, so it would be a -4. That might be a good example. Or you might even see something like -8 over 4. Well, that reduces to -2. So that is also an integer. All right, rational numbers are all the other numbers that we did not talk about, all of the decimals, right? Let's pick a different color. Let's do orange. So the rational number symbol is Q. We talked about that already. And for the rational number, you have 0.34. That might be an example. It does also include -1, right? It also includes 0. A rational number, you might see -7 over 11. Or what's important to remember, a repeating number is a rational number, right? If I have that line over, I know it's 0.252525, repeating, right? All right, that is rational. All right, now the irrational numbers we just talked about, one example might be pi. Let's use green already. Let's do light blue. So for irrational numbers, we use the symbol I, and an example would be pi. Okay, or we might have the square root of 5, right? The square root of 5 cannot be simplified to a rational number because there's no perfect square root of 5. You might have the square root of, let's say, 20. Yes, we can simplify that to the square root of 4 times the square root of 5, right? And then the square root of 4 simplifies to 2. So we would have 2 times the square root of 5, but we're still left with something we cannot simplify, something in the radical, so it is not rational. Okay. All right, let's go ahead and go down and look at a few examples. Here we have the square root of 30. Well, we just talked about that, right? When we simplify that number, it would look something like the square root of 5 times the square root of 6. So this is actually an irrational number, so we would write R, but every number is a real number in this system. So we would, I mean I, so we would also write R, excuse me. All right, so let's look at another one that kind of throws some of you guys off. We have the square root of 16 over the square root of 16 over 25. So we would actually simplify this. So this would be the square root of 16 over the square root of 25. But we know the square root of 16 reduces to 4, and the square root of 25 reduces to 5. So this actually makes sense. This is a rational number. So I would write R. And it is also a fraction. which is also q. So the fraction is our rational number, and r is for our real number. Excuse me. All right, let's look at this one. Well, we're going to talk about um, our properties in just a minute, but this basically simplifies to 1. Right? Anything over itself always reduces to 1 because the square root of 7 divided by the square root of 7 equals 1. Even though the square root of 7 itself on its own is irrational, but they're canceling each other out. So that simplifies to 1, and 1 would actually be everything, right? That is a natural number, so we would write n. It's a whole number. It's also an integer, a rational number, and we already established it's not irrational, okay, because it can't be rational and irrational. And it is also R, a real number. Okay. All right, we're going to go ahead and shift gears a little bit, and we're going to look at the properties of real numbers. So the properties of real numbers, I'm not going to make you guys memorize the names, okay? I'm not going to make you memorize commutative, associative, identity, inverse, and distributive, because I don't think that matters as much as the actual concepts of these properties. So the commutative property is going to be, for an example, A plus B is always going to equal B plus A. Even though we switch these numbers around, it doesn't change the value. Okay, so you might even say 1 plus 2 equals 2 plus 1, right? And so that's a pretty simple concept, pretty straightforward. We might see that in multiplication a little bit differently. It might say A times B equals B times A. Okay. The associative property is going to be A plus B in parentheses is plus C on the outside is the same thing as A plus B plus C, where these are in parentheses. And the reason why is because we know the addition addition doesn't have those special rules, right? Where when you're adding, it doesn't matter what order you add. So that's the concept of this property. And the same thing goes for multiplication, where if we have A times B in parentheses times C, it would be the same thing as A times B and C in parentheses. Okay. Because multiplication and addition don't have the special rules, such as subtraction, right? If I have A minus B, it's not going to be the same thing if I do B minus A, right? We understand that. So if I have 5 minus 2 is not going to be the same as 2 minus 5. My 5 minus 2 is 3, and 2 minus 5 is negative 3. We can see that does not work. But so that's why we see the additive example and a multiplication example, addition example, multiplication example. All right. All right, let's do the same thing for identity. Identity is if I have, for addition, if I have A plus 0, it's going to equal A. No matter what the number A is, it's anything plus 0 is always itself. And the same thing goes for multiplication, except not multiplying by 0, but by 1. A times 1 equals A. B times 1 equals equals B, right? Just because we're multiplying, but because we're multiplying by 1, it doesn't change our value. You might even see this as 1 in front of a letter B is just going to equal B. We don't write that 1. It's understood that there's a 1 in front of that variable, but we don't have to write that. Alrighty, the inverse property. One way that you guys are pretty familiar with the inverse property is when you cancel something out. So you can write that down. Cancel out. When you cancel something out. So for an example, if I have A plus negative A, my answer is going to be 0. Okay, we canceled out the A with its opposite, right? The inverse property. So let's see multiplication. If I have A times 1 over A, it is going to be 1. We cancel out A by flipping it and multiplying it. Okay. The distributive property, you guys are pretty familiar with how that works. We have A times B plus C is going to equal, we distribute the A times the B and the A times the C. So it's going to be A times B plus A times C. All right, so here we have where they want you to name the properties, and these I'm going to let you guys do on your own, but I want to take a look at number 21 so it doesn't confuse you. So they're saying name the additive and multiplicative inverse of each number. So what's the inverse when you're adding, right? What's the inverse of -8? Well, it's going to be +8, right? Because if I have -8, I'm going to cancel out the -8 with a +8 to get 0. That's what cancel out means, to get the value to nothing, okay? If it's multiplication, you might have -8, and remember, you're trying to get the value to be 1. So what are you going to multiply 8 by to get to 1? You're going to multiply, sorry, -8. You're going to multiply -1 over 8, right? We just flip it. It would be if -8 was over 1, you flip it and you multiply, it turns into a 1. So the opposite of -8 when you're multiplying is going to be -1 over 8. All right, same thing here. If I have 2 over 3, how am I going to cancel this out using addition? Well, I'm going to add a -2 over 3, right? So if I'm adding a -2 over 3, it cancels out and my answer would be 0. So my additive inverse operation is going to be -2 over 3. Right? Same thing goes for when we're multiplying, we're going to flip the number. So if I have 2 over 3 times, we're going to flip it. 3 over 2 is going to give me 1. So 3 over 2 is the answer for that one.